Earth's motion. Okay, here we go. This is a Foucault pendulum. Okay, you probably have seen it. I have one representation of it here. A Regent's diagram shows it this way. Another one shows it like this, and it shows the hours here. There was probably a lot of explanation that goes along with it. Here's another a different picture, I believe. Yeah, this is a different picture showing the same thing. And a Foucault pendulum, it proves that Earth rotates on its axis. This was done in France. And Foucault actually created an experiment that proved it. And hopefully you really got this in class, because it is a really cool thing. But know that for this purpose, Foucault pendulum is proof or evidence that Earth rotates on its axis. Other pieces of evidence while we're on it, this is a common topic as well, proof that Earth rotates, is star trail. So for instance, if you look up in the sky, and we're able to take like this would be a time-lapse photography, this would be around Polaris, and you see how the stars appear to move. This is evidence that Earth rotates, actually, and Earth rotates 15 degrees per hour. I'll throw that. This is another important fact. So therefore, if this moved 90 degrees of arc at 15 degrees per hour, I know that this picture represents 6 hours of time, of a time lapse. So that's cool. Other evidence that Earth rotates is the Coriolis effect. This was covered in the weather unit if you've watched that video already, but Coriolis effect is the curving of winds on Earth. They curve to the right in the northern hemisphere and to the left in the southern hemisphere. Also evidence that Earth rotates. Make sure you know these. They're important. Now we're going to get into Earth's revolution. Earth revolves around the sun. It takes 1 year, 365 days for that to happen. What are some pieces of proof or evidence that that happens? So what this is trying to represent is, here is the sun and a very much not to scale version of Earth revolving around the sun. This is trying to show different constellations that out there in space. Now, it's hard to show in any kind of diagram because they're so far out there in space, but this is what they're representing. And this is sort of where they are in space. And we see our nighttime sky faces different areas of space at different times of the year as we go around the sun, and that is evidence that Earth revolves. So for instance, the question that went along with this diagram is this: why are some constellations visible to New York State observers at midnight during April, but not visible at midnight during October? And the answer is Earth revolves around the sun. So that seeing different constellations when you look in the sky at different times of year is evidence that Earth revolves. This is another representation of it. So this shows always towards the southern sky, because you look towards north, you kind of always see Polaris towards north, but towards the southern sky, that's where you see these. It shows the constellations you see in July, and then 6 months later, or whatever that may be, you see very different constellations. And basically the question is, which motion is mainly responsible for the difference in the constellations visible at midnight on these two dates? And the answer is 2. Earth orbits the sun. Know it.